Hi, sir. So let's say that we have a point here with the yellow hole that is 0, 0. And then if I want to go in that direction, so I'm mining and I place down some water to just say that it's a negative vector because I'm going toward the negative side. But if I want to go toward the positive side, which means that it's this way, so I'm going to dig that way, place some water, place a different color and say that it's positive. So now we have a point that is 0, 0, 0. We have a negative vector is going to the left, and we have a positive vector going to the right. After that, if we say that a vector called v is 3 block wide, going from right to left, so it's positive, and we have another vector going from left to right again, that is still positive. So if we add them up, which means that let's say its magnitude is the number of blocks that is traveling, that the water is traveling. So 1, 2, 3, 4. Well, one with 4 and the other one with 3. So if we add them up, we have 1, 2, 3, and 4 plus 1, 2, and 3. Thus, thus obtaining this long positive vector that is going toward the positive size. But if we take the both same vector and we say, let's say that this is v minus u, v is the 4 wide vector and u is the 3 wide vector. So by subtracting it, we're going to change this aside, so it will go instead from right to left, you go from left to right, thus becoming negative. So the result of that will be 1, 2, 3, and 4. This one, but the when we subtract the second one, we go the other way. 1, 2, and 3. So if we say that this was their starting point, the flow will go in both direction. But in fact, if we subtract them, so let's 1, 1 each side, 1, 1, 1, and yep, that's it. So each sides have removed have been removed, and this is the resultant that is positive. So if now let's say that we have a vector called t that is 5 wild, 1, 2, 3, 4, 5, 5 block wild, and we have, let's say, a scalar number 3. So we want to um, do this vector but 3 times more. So 1, 2, 3, 4, and 5. So we have 1, 2, 3, 1, 2, 3, 4, and 5. So here will be the start of our new vector of the second part of this vector. And if we add another one of 5, 1, 2, 3, 4, and 5, it will give us an even bigger vector. Thus, this is kind of a dot product since we are multiplying a vector by a scalar number. So, in our case, if we have, let's say, a vector going up dirt box, let's say it's that big, and this is the arrow, and it's only in y-axis, and we want an orthogonal projection of it. Well, it's pretty much going to be orthogonal mean perpendicular, so you don't need to pass through it, but it need to be perpendicular of it from it. So let's say we have x and y axis, so we need to move it move it a little bit, and let's move it like that with no connection, and we still have, well, the direction don't matter, but we still have. So like that, we see that there's only one vector, but if we shift a little bit, there will be a projection towards a projection behind it, and they're basically both the same vector, but not with the same height, but it's just a projection of the first one. And now a unit vector is a vector that is that its length is only one. So let's take the yellow wool. Let's say that this is a vector, but the vector is only one. So the magnitude, let's let's say the magnitude of yellow is 1. So this this block, this vector, even it's represented with 4 block wide, its magnitude is going to be 1. And an orthogonal vector, let's retake the orthogonal projection. If we break the projection, orthogonal vector are perpendicular to the first vector. So if we make one, but they need to touch. So we can say that the vector that I just created, that is going from on the z-axis, is orthogonal. It's an orthogonal vector of the first one that is on the y-axis, since it's touching and it's perpendicular. But let's take a vector going the yellow vector going on the x-axis, wide of magnitude of 4, and we want its normal. A normal vector, it's a perpendicular vector um, of the initial vector, but it's going upwards. So let's take strip jungle wood, and it's going to go up just like that, and this is the normal vector. So it's perpendicular, it's 90 degrees here, and it's going upwards from the initial vector. Even if the vector will be an angle, let's say this is the same vector as this, as the yellow one. Let's say they're both the same. I just move it upward a little bit more than its flight in y. The normal vector will be perpendicular to it, so it will kind of have this shape, but in Minecraft it's not very useful to represent it since it's a linear game, if you get it. And lastly, parallel vectors. So let's take diamond blocks, why not? Because we're rich in Minecraft. And we say that this vector is, it's from 0.00, so 0.00 is here, the yellow block, going to this point, let's say 1, 2, 3, 4, 5, 6, so 600, and we take another vectors and we move it with the same magnitude. They don't need to be same magnitude, they just need to have the same length, no, the same variation, the same m, let's say in ax plus b or ax plus by plus c, they need to have the same a so that they move at the same speed. Not the same speed, they have the same variation, they have the same delta x on delta y. Thank you.